Do you know Google runs its Gmail, YouTube, search, and most of its apps inside containers? Google runs average of 2 billion containers every week. That is billion with B. So containerizing apps allows Google's development teams to bring new products to the market quickly and operate at unprecedented scale to meet the demand. And they have been using these containers since more than a decade. I guess this one fact is good enough to know about what are these containers that everyone is talking about. Hello and welcome to Containers. So next few minutes, I'll try my best to get you up to speed on containers if you are new to this topic. So without any further delay, let's take a look at the things you will be learning in this video. There are 5 major things that we'll be discussing as part of this. First, we'll discuss about what are containers in general. And this has nothing to do with containers in IT. But that will give you a good starting point for the next thing we are about to discuss. And that is, what is container in IT? I guess this is what we are all are interested in, right? There, I'll explain you what are containers in IT and why we need it. Then we'll look at the container architecture. So once you get comfortable with it, then we'll discuss about some of the important advantages of containers. And finally, we'll discuss about the top 2 container engines that runs these containers. So that's about the overall plan of this video. And with that, let's get started with our first thing in this video, and that is what are containers in general. This was a picture about a half a century ago, I guess. So what do you see in this picture? If you're seeing what I'm seeing, there is a ship parked in the dockyard. Also you see the people moving goods which are packaged inside a box onto the ship. And that box is called as container. Back in the days, there used to be a container depending upon the size of goods we are shipping. For example, there is a one type of container to ship a car, and there is a different size of a container to ship a bike. So we have a different sizes depending upon the size of goods we are shipping. So in between start and end locations, these goods can be loaded and unloaded, stacked and transported over long distances and transferred from one mode of transportation to another mode. As you can see, the scene above looks very confused and chaos. Luckily, things are not same now. Fast forwarding to now, there is a standard size of container to ship goods across the globe. The current ISO standard size of a container is 40, 20, 10 and 8 feet. Here we have a one big container where we can fit multiple goods fit inside, sealed and transported to the target location. So the key takeaway point from here is we can package multiple goods of different sizes inside a container, then ship from source to the target destination. These are containers in general. So reason for talking about this container in our discussion is the concept behind this is closely related to what we are about to discuss in next slide, which is what are containers in IT? So before I explain about that, let me tell you why we need containers in first place. Imagine that you're building an app. So you have multiple components to that app to stick together. In general, you have a web server, you have an app server, you have a database, you have a caching layer, you have a messaging server, and some more components to it. Let's assume that file your app is ready. So the question is, where do you run this app once it is ready? For most part of time, we had 2 options. They are on physical servers and the other is virtual machines. And for the last 3-4 years, we had something called cloud. But there are 2 problems that we come across when designing and deploying apps onto these runtime environments. They are portability and compatibility. So let me ask you one question. Are you sure that is your app is portable to run anywhere without any compatibility issues? Meaning, will your app run on physical servers, VM, cloud, Windows, Linux, or simply anywhere without any issues? Even though you found a way to run it, but can you expect to have your app behave same across wherever you run it? So let me rephrase this question. How can you run your apps anywhere? And let me say this as well. Welcome to containers. So what is container and what does it do? In simple terms, containers will package all your application code and its dependencies and ship it to a public or private repository and then download and run it anywhere. Yes, your application will behave same wherever you run it. Currently, there are multiple container technologies to help us with it. Out of all, there is one container technology that is way ahead of others, and that is Docker. Container and Docker became synonymous to each other. We'll discuss about the Docker in next video. So the key takeaway point from here is containers are here to help us to deal with compatibility between various versions of components in software apps and makes your apps portable to run anywhere. Now let's see where does these containers sits in our infrastructure stack in next slide. So if you look at the basic infrastructure stack with the container, it will look a bit similar to VM stack. So down at the bottom, we have a physical server. On top of that, we have an operating system which could be Linux or Windows. So far this is familiar to most of us. But now comes the component which makes us unique, which is container technology. There are multiple container technologies that you can install on top of Linux or Windows. As discussed earlier, one of them can be Docker or other can be Rocket, in short RKT. So once you install this container technology, on top of that you can create multiple containers. Well, looking structurally, this is almost looks similar to infrastructure stack with VM, but with one major difference, and that is virtual machines virtualizes at a hardware level, whereas containers virtualizes at an operating system level. Again, virtual machines virtualizes at a hardware level. So whereas containers virtualizes the operating system. So you can have a multiple containers created on top of one operating system. So what does this container actually contain? These containers contain only required libraries and app services. So there are multiple benefits by virtualizing at an operating system level. Let's quickly see what they are. First, container becomes very lightweight since there is no full-fledged operating system. Next, it boots up in a matter of seconds. And finally, it takes about fraction of disk and memory space. So these are the high-level benefits from an infrastructure stack. Now, let's take a look at other benefits and advantages of containers in next slide. First and major benefit of container technology is portability. Imagine that you are developing an app and you have a code, config files and its dependencies on your laptop. So let's assume file your app is finished and running successfully. So to behave the app same everywhere with no compatibility issues, for that you need to take that app and its components and package it together and containerize it. Once that is done, you can run your app anywhere from your local laptop to physical servers, VMs, testing, staging, production environments, or public or private clouds, or simply anywhere. So this is all possible using the container technology. Next benefit is resource efficiency. Since containers do not require a separate operating system, as a result, they use up very less resources when compared to VM. So the size of VM typically measures in several gigabytes, whereas container it measures only few megabytes. And that makes it possible to run many more containers than VM on a single server. As a result, containers have higher utilization level of hardware and that brings down the data center cost. Next benefit is isolation. Although multiple containers run on same server and use same resources, but they do not interact with each other unless and until required. If one container application crashes, other containers with same app instances will keep running flawlessly and won't experience any technical problems. This isolation also decreases the security risk. For example, if one app should be hacked or breached by malware, any resulting negative effects won't spread to other running containers. So that's about the isolation. And next benefit is speed. As we mentioned before, containers are very lightweight and start in less than a second because they do not require a full-fledged operating system to boot. So creating or replicating or destroying containers is also just a matter of seconds. Thus, greatly speeds up the development process and then time to market new products as well. And the final benefit is scaling. Scaling is one of the important benefits of containers. They offer the possibility of horizontal scaling, meaning you can add identical containers within a cluster to scale out. So with the help of smart scaling, where you only run the containers which are needed in real time. As a result, it reduces your resource costs drastically and accelerates your return on investment. Container technology and horizontal scaling has been used by major vendors like Google, Twitter, and Netflix and for years now. So these are some of the important advantages of containers. So now it's time to discuss what are the top 2 container technologies out there. We'll see that in next slide. There are 2 popular container engines out there now. As discussed earlier, one is Docker and other is Rocket. Rocket is oftenly called in short as RKT. So here, Docker is from Docker Ring and whereas Rocket is from CoreOS. From these 2 container engines, Docker is one of the most popular and widely used container engines. Docker and containers are synonymous to each other. Docker is container and container is Docker. We'll discuss about Docker in a separate dedicated video. So that's about the container engines at a very high level. So far we have discussed about what are containers, why we need it, and its advantages. And now it's time to wrap this up. So before we end this video, let's go through some of the important points that we discussed in this video in last few minutes. So coming to the summary, there are 5 major things that we discussed as part of this. First, we discussed about what are containers in general. And this has nothing to do with containers in IT, but that gave a good starting point for the next thing we discussed, and that is what are containers in IT. So containers will help us to package all your app code and its dependencies, then ship it to the public or private repository, and finally download that containerized app and run it on your laptop or physical server, VM, cloud, or simply anywhere and expect to behave in the application same across. Also, containers helps us the virtualizing the operating system. As a result, you can run multiple containers on a single machine. Then we discussed about where do these containers fit inside the infrastructure stack. You can install container engine on top of Linux or Windows operating system. After that, we discussed some of the important advantages of containers. They are portability, isolation, resource efficiency, speed, and scaling. Finally, we discussed at a very high level about 2 top container engines. They are Rocket and Docker. Docker is from Docker Ring and whereas Rocket is from CoreOS. Very recently, CoreOS is acquired by Red Hat. So that's about the containers at a high level. And next coming up, comparison of three runtime environments, which are physical servers, VM, and containers. In that video, we'll compare the runtime environments such as physical server, VM, and containers. And we'll see why containers are best suitable for running microservices. And finally, thank you so much for watching this, and I hope to see you in the next video.